Why is polyglot persistence crucial for microservices' success? Imagine building a city where each neighborhood has its own style, infrastructure, and rules. In the same way, microservices need different types of databases to work best. That's where polyglot persistence comes in. It means using various database types within a single system, each chosen for what it does best. In a microservices setup, each service is like its own little business. Some need to handle lots of transactions quickly, like payment processing. Others might store unstructured data, like product descriptions or user comments. Some need to connect complex data points, like social network relationships. Using one database for everything can slow things down or limit what each service can do. Polyglot persistence allows each microservice to pick the perfect database for its specific needs. For example, a service managing financial transactions might use a relational database because it guarantees data accuracy and consistency. Meanwhile, a product catalog service might use a document database that easily handles flexible data structures. A recommendation engine could use a graph database to map relationships between products and users. And a caching layer might use an in-memory database to deliver data super fast. This approach helps each microservice perform better because it uses the right tool for its job. It also makes the system more flexible and easier to scale. If one service needs to grow, it can do so without affecting others. Plus, teams can choose databases they are familiar with, speeding up development and making maintenance simpler. Of course, managing many different databases adds some complexity. It requires more skills and careful coordination to keep everything working smoothly. Some organizations limit the number of database types they use or combine multiple data models into one database engine to reduce this challenge. In real-world systems, polyglot persistence makes a big difference. It allows each microservice to operate independently with its own optimized data store. This means faster performance, better scalability, and more flexibility. For example, in an e-commerce platform, user login might use a relational database, product info a document store, recommendations a graph database, and caching an in-memory store. Each one is chosen to match the specific data and access needs of that service. In short, polyglot persistence aligns perfectly with the core ideas of microservices architecture. It helps services run efficiently, evolve independently, and handle their data in the best way possible. This makes the entire system more robust, adaptable, and ready to grow.